Hey guys, welcome to question FM166 of the Further Maths Fortify study guide. This question reads, Carly borrowed $90,000 at an interest rate of 7.2% per annum. Interest is calculated monthly on the reducing balance of the loan. The loan will be fully repaid with monthly payments of $975. Now, very early copies of our book will say $950 here. If you change both the $975 in this initial description and the $950 in option D to $975 and have a go at this question, you should be able to get a correct response. So continuing on, which one of the following statements is not true? Emphasis on that not true there. So option A, her final payment includes interest. Option B, her second payment reduces the loan by more than the first payment. Option C, her first payment reduces the loan by less than $450. Option D, repaying more than $975 per month will reduce the term of the loan. And option E, her final payment will be less than $891. Cool. So jumping straight in, we know here, if you're able to notice about the initial scenario, we're not actually given a time frame for how long this loan lasts for. So what we might do first, just to get a clearer picture of exactly how this loan is working, is put in the information that we know. So we know that it's 7.2% per year. She's borrowed $90,000, so it's a positive value of $90,000. We've got payments of $975 being made each month for a future value of 0, because it is to be fully repaid. Payments per year are at 12, and compounds per year are at 12. So plugging all of this into Finance Solver, we should get an answer for n of 134.91838 and so on, which tells us this 0.91838 is telling us that we've got 134 full payments of $975, and then we've got one payment of some altered amount, and we'll see if that sort of comes in handy a little bit later as we work our way through the potential answers. Now the first option A, says her final payment includes interest. Now, you guys should be starting to get familiar with how these situations work, how these loans work. Yes, every payment that is made back on this loan is going to include interest. That's how they're calculated. So option A is immediately scratched from our list because that will be true, which means it is not our answer. Option B says her second payment reduces the loan by more than the first payment. Now you could use Finance Solver to calculate this. I'm going to do some straight calculations so you guys can kind of see how it's all working, how it's all happening. So our first payment of $975, we can calculate how much of that is going to go towards interest by looking at the fact that during our first payment, we will owe $90,000. Now, we know that we have a yearly interest rate of 7.2%, and our payments are being made monthly. So if we were to divide that by 12 and whack that over 100, completing this in your calculator, you'll be able to see that this will give you $540. So on our first payment, we're going to owe $540 of that to interest, which means if we're making payments of $975, if we subtract $540 for interest, $435 of those dollars is actually going towards reducing the principal or reducing the value of the loan. So that would have been payment number 1. Now, if we've got a loan of $90,000 and we've reduced the value of that loan by $435, then the new value of our loan after one payment will be $89,565. Once again, calculating the interest on that amount, we've got $89,565 times 7.2 divided by 12 to take it into a monthly percentage, all over 100 to change those percentages into decimal values. That is going to equal $537.39. So now we've got $537 owed to interest. You'll notice that we have less owed to interest than before because the value of our loan is less, which means that we're going to have more to pay towards reducing the value of our loan. So 535.39. That should equal $437.61. So option B, her second payment reduces the loan by more than the first payment. Yes, it will. Therefore, option B is also not our answer, as it is correct. Option C, incidentally, while we have this working available to us, option C says her first payment reduces the loan by less than $450. We can see here that it reduces the loan by $435. So yes, that is true. Once again, that is not our answer. Option D says repaying more than $975 per month will reduce the term of the loan. Yes, of course it will. If we're paying more back on our repayments, that means that we will still owe the same amount of interest that we calculated before. So the first lot of interest it was calculated at $540 in our first payment was going to go towards interest. If we're making greater payments, so just to show you that again, that $975 in a payment, if we're going to minus $540 from that, we'll be left with $435 to reduce the loan. If our payments were greater, say we're making payments of $1,000 instead, and we were to reduce, would take off $540 for interest, then we would have $460 going towards repaying our loan. Therefore, bigger payments are going to pay off that loan faster. So option D, being correct, is not our answer. Option E is looking like it's going to be our correct answer, but we want to know for sure that it is our correct answer. So for option E, her final payment will be less than $891. This is a tricky question because the way to solve this can open itself up to a few mistakes being made. If we put in 134, we know there's 134 full payments, and then one after that. So if we put in a value for n of 134 exactly, and then calculate a future value, we're going to get a future value of $890.30. Obviously some decimals coming after that, but we've rounded it to this amount. Now, the tricky part here is that a lot of students, may take this answer to be the final payment that will be made. This is the future value, ergo in this scenario, it's the value of the loan after 134 payments of $975 have been made. This value of the loan doesn't actually contain within it the interest that will be owed at this point either. So we take this value of $890.30, and in order to also add on the interest that will be owed at this point, we're going to times that by 1 plus. So we obviously want to keep this value and add interest on top, hence the 1 plus our 7.2% per year divided into 12 to turn it into a monthly amount over 100. Plugging this into your calculator, you're going to get $895.64. Of course, there's some decimals around there, but that gives you sort of a fair indication, which means our final payment, we've got 134 full payments of $975 and one payment of $895.64, which puts us over that $891, which means that E is false and is our correct answer. That's a tricky one, guys, so if you have any questions about that, please drop them in the comments below and we'll get back to you. Otherwise, I'll see you in the next video.